but not necessarily working, right? So,
yeah, why not?
So let's see.
We have been working for that, like Lorenzo was calling that yesterday till 3 a.m. and.
Well, to be fair, Dan Brown wrote the user space code that does this, and he also has an implementation of the framework changes, the Android changes as well. So there should be slides. Wow. So yeah, so this is essentially the problem that Cameron was talking about just about half an hour ago. So you have this IPv6 only device, right? For various reasons, it's hard in the mobile space to provide both an IPv4 address and a v6 address at the same time. We're not going to go into those reasons, but if you can only do one, what ends up is that you only do v4, because you can't not have v4, but you cannot have v6 today, right? So what happens is, okay, so you give the phone an IPv6 only address. All right, so the phone can go to do a stack website like Google or Facebook or Yahoo, fine. But it can't go to CNN or to Twitter, okay? So you can't sell that phone, right? Because the customer will return it. Okay, so then you say, okay, well, I'm going to put a NAT64 there. And the NAT64 makes Twitter work, okay? So you can go to all of that long tail of content, web content, that works with the NAT64, right? The server is IPv4 only, but the NAT64 translates IPv6 into IPv4, and you can get access to the content that you want, okay? But if the application doesn't support IPv6 at all, for example, Skype, okay? That doesn't work, because that application only works if there's an IPv4 address on the handset, okay? So what happens? 464 xlat gives the handset a dummy IPv4 address. When the handset uses that dummy IPv4 address, it intercepts the packet and translates it to IPv6 in a way that is reversible by the NAT. So basically, if the NAT twiddles bits between IPv6 and IPv4, the 464 xlat first untwiddles them so that when they go through the NAT, they get twiddled again, and v4 comes back out. So this is kind of how we tried to draw it. I don't know if it's very clear. So the green is basically just native IPv6, right? If you're going to Google, or if you're going to Facebook, or to any v6 website, you'll just use IPv6, right? Is there a laser pointer? No.
Yeah.
Oh, there is.
Oh, there we go.
Okay. So the green is native IPv6, direct. The darker green is the medium green. I swear this was green on my screen. But, so the medium green is IPv6 going through NAT64 and going to, say, Twitter, or any other IPv4 website that works behind NAT64. And the dark green, which, okay, looks black, but it's dark green really. Basically, what the handset does is it thinks it has this IPv4 address, but the packet actually loops back inside the handset to the CLAT daemon. The CLAT daemon, in v4. The CLAT daemon translates that to v6 locally, and then the handset just sends it out to the NAT64. The NAT64 undoes the transformation, and you can now use Skype. So let's see if it actually works. The hard part actually is not getting 464 xlat to work. The hard part is getting v6 data roaming to work, because it is hard to find a combination of network, network, phone, and so on, and country where all of this stuff works at the same time. So
these packets are now flowing back to Slovenia to SIM mobile operator.
So the combinations that are known to work are a Norwegian SIM here and a Slovenian SIM here, not an American SIM, and never in Japan, ever, because it's blocked. Okay, so those are the known combinations. Okay, so I'm going to run, this phone is, I'm going to show it to you later, but I'm going to run 2 TCP dumps, okay? So one of them is, this one here is going to be, the top one is going to be a TCP dump of the CLAT interface, which is a separate link, okay? It's this virtual loopback thing that processes the packets and translates them, okay? And the one below is the actual radio interface, because I'm connected to a 3G network. So let's see. Before I do that, I can actually do. I don't know if you can read it. Maybe you can. But there's a global IPv6 address here. Okay. And what? Oh. Oh, because it's peer-to-peer. Okay. No, wireless is off. There is no v4 address.
ADB shell.
No. Thank you. Okay. It was kind of confusing. Okay, so that's my real v6 address on the mobile network. That's the Slovenian prefix?
Yep.
Yeah. Okay. And the v4 address, this one is, the astute observer may notice that this is actually the dual stack light address. It is reserved by IANA for the purpose of v6 to v4 translation, so we figure until we can change the RFC, this will do. So anyway, so let me make the window the same size again, and I'm going to run cspeed dump on the actual radio interface. So now, let's see. So I can
show them the phone.
Can we show the phone here? But not at the same time, huh?
Should I call you?
No. Let's.
Are you on Skype now?
Yes, I am. Oh, you said somebody texted me. Can I be the other side of the demo? Yes. No, you cannot. I'm doing a demo here. Hello, Martin. Wherever you are. There you are. Hello, Martin. Martin is on. Can you see this? Yeah. Martin is sending me more messages. And Jan is calling me. Okay. All right. It's just accepted. Hello, Jan. Jan Zorz cannot see as your video is off.
Hello.
Hello, Jan.
Is my video on? Yes, it is.
Yeah?
I'm connected here to this network.
So, there are your v6 packets, there are your v4 packets. If I close Jan, and I can actually close Skype, so that we can get on with it now.
Were there some packets? Yes, there were.
Yeah, there were packets, of course. If I log out of Skype, I can actually go to a website and, I don't know, IPv6test.com, and you'll see that most of the time it's just using v6 because the NAT64 translates the v4 only servers into v6 servers, so we don't end up using the evil loopback mechanism at all, right? It's only for those cases when the application actually really wants to connect over IPv4, right? And doesn't support anything else. Okay, this is IPv6 test. I mean, we could run lots of apps here, and Google Maps. Who's paying for this? So yeah, so Google Maps is using v6. Everything just uses v6 because Android prefers IPv6. And so you basically just don't use the mechanism for anything at all. Notice that the top window is not scrolling at all. So anyway, so this is how it works. Thanks to Dan for writing the code. Thanks to Cameron for persisting in his battles and getting it standardized. And it took a while. Thank you to Tore for actually giving me the stuff that I could test yesterday, because we haven't got this combination working today. So yeah, if there are any questions, we can have time.
Now, actually, we removed the last speed bump for you mobile operators that were standing between you and handing out the v6 only handsets. So, time to go home on Friday and start working.
Actually we haven't, because this is not released code.
Well, okay, you were asking me for this. When?
This is a proof of concept demo. So having a test setup that I could actually use would help.
It's good enough.
But I live in this kind of blacklisted country where IPv6 doesn't work on the mobile network. The actual answer is I'm not an Android team member and I cannot comment on future releases because I don't know what the plans are. But there is running code. Is the answer to that. And
this can also do tethering, right?
It can do only IPv4 tethering for now. IPv6 tethering is more complicated to get right. It's easy to make it work, and then it's kind of harder when your address lifetimes change. It's kind of harder in the general case, because you have to be very careful in what happens. You have to make sure that you stop the array when you lose your connection and so on. I haven't seen any implementations, but I can imagine that
That proxy, that's
complicated.
you were working on that proxy.
64 share?
Yeah. Okay. So, thank you.
Okay,
any questions?
So any questions for this one? That's wonderful set of speakers. One question up here.
No, not the usual suspects.
Tor Andersson, Red Limbro. I had a discussion in the break about how a mobile operator can actually enable V6, because you need V6 for this to actually work, right? So if a mobile operator enables V6 or even dual stack in their network, Android will still request V4 by default. So how can an operator actually roll it out in such a way that Android will use the V6 PDP context or the dual stack PDP context?
So Android won't use V4. Android will use whatever's in the configuration file.
Yes, and that is
so that's actually not that simple. So when you boot your Android for the first time, it takes a configuration file and it writes it into a database. I'm not aware of, I don't know if the database can be changed, but the configuration file can be changed. And if your network is production V6 ready and you want to use V6 and it's going to work, then I would imagine that you could send email and say, please change the default to V6. And then all the phones that you get will try V6, right? Only V6. So you want to do that only if you're ready for that to happen.
All right.
And you probably need something like this working before you would do that.
All right, but if you actually change the default in Android for that operator, what will happen with the phones that don't support IPv6 on the mobile interface?
They can't call it before.
Well, so that, yeah. So there's no good reason to, there's no good way to do that, right? So you would have, yeah, you can change it. So the short answer is that the OEM can always change it for the particular phone. You can always spin a custom build for a phone that doesn't, right?
If the provider is actually selling the handset, but if you buy it at an electronics store,
it will just do V4.
Right. Yeah, we'll do V4, but that's not what we want. So I don't have an answer for this. It's something that we should talk about. Do you have an answer? Yeah.
I don't know.
No. Okay. We need. So, but you're right. We need an answer for this. I don't have one.
Right. Thank you.